Let's dive right into a massive shift happening in modern American military aviation. You know, for over a century, control of the skies has pretty much dictated the outcomes of wars. But how that control is actually achieved, well, that is completely transformed.
So when I say the word dogfight, what pops into your head? If you're like me, you're probably picturing a scene straight out of Top Gun, right? Jets twisting and turning at breakneck speeds, pilots pulling insane G-forces, chaotic close-range battles with machine guns firing. It's an awesome image, for sure. But here's the thing. It's fundamentally outdated. Today, modern air combat is rarely decided by who can pull the tightest turn.
The whole paradigm has completely flipped. The old way? That was all about raw speed, maneuverability, and physically seeing the enemy with your own two eyes. But the new way is all about stealth, moving massive amounts of information, and fighting well beyond visual range. Modern fighter jets aren't just fast airplanes anymore. They're essentially highly advanced flying computers where data is the ultimate weapon.
So here's our flight plan for this breakdown. We're going to start with the information revolution, then move into the masters of stealth, check out the heavy hitters, zoom out to the networked battlefield, and finally, look at the future of air power.
First up, the information revolution and how it's changing the rules of the sky.
Think of a modern fighter jet, less like a plane and more like a flying command center. Victory no longer hinges just on who has the most firepower. It hinges on sensing and processing the battlefield faster than the other guy. The core philosophy driving decades of aerospace engineering boils down to this: the fighter that sees first, understands first, and acts first usually wins. Think about it. If you can detect an opponent and launch a weapon before they even know you're in the same zip code, their speed and maneuverability literally don't matter.
Moving on to Section 2, Masters of Stealth, the Invisible Vanguard. To actually see first and act first in aircraft has to survive heavily defended airspace, and you do that by becoming effectively invisible to radar. A perfect example is the F-22 Raptor. Its very shape is engineered to scatter radar energy away from enemy sensors, and it hides its weapons internally so external missiles don't create any radar reflections. But what's really wild is something called super cruise, the ability to fly at supersonic speeds without using fuel-hungry afterburners. Combine that with thrust vectoring nozzles that actually physically change the direction of the engine exhaust, and you've got a stealth fighter that can still outmaneuver almost anything in a traditional dogfight.
Now take that concept and push it even further with the F-35 Lightning II. If the F-22 is pure, unmatched air dominance, the F-35 is, well, it's the ultimate flying computer. Think about the technological leap from an old flip phone to a modern smartphone. That is exactly what the F-35 represents. It's a multi-role stealth fighter designed to completely dominate the battlefield by combining precision strike, intelligence gathering, and networked communications all into one airframe. And the Joint Strike Fighter program did something really clever here. Instead of building totally separate aircraft from scratch for the different military branches, they created three unique variants of the F-35. The F-35A uses standard runways for the Air Force. The F-35B has this incredible lift fan that lets it do short takeoffs and vertical landings for the Marines. And the F-35C features larger folding wings and beefed-up landing gear to handle the brutal demands of Navy aircraft carriers. So you have three distinct missions, but they all share one incredibly smart technological brain. Let's geek out for a second on how it actually works. The F-35 uses something called sensor fusion. Basically, the jet sucks in mountains of data from radar, satellites, and its distributed aperture system, which is just a fancy way of saying a network of infrared cameras giving a 360-degree spherical view around the plane. The onboard computers merge all of this into one clean, easy-to-read tactical picture. And get this, there is no traditional heads-up display on the dashboard. Everything is projected directly onto the pilot's visor. The pilot can literally look down, and the helmet projects live camera feeds so they can see through the floor of the aircraft. Absolutely mind-blowing stuff.
All right, Section 3, the heavy hitters. Proven power and massive payloads.
As incredible as stealth is, not every single mission requires invisibility. Sometimes you just need sheer, undeniable power, and that's why heavily armed, 4th-generation plus fighters remain absolutely vital. Take the F-15EX Eagle II, for instance. Unlike a stealth fighter that has to hide its weapons in small internal bays, the Eagle II is a literal flying bomb truck. Because it features a modern digital architecture and advanced radar, it has all the modern brains, but it can carry an absolutely massive external payload. We're talking air-to-air missiles, precision-guided bombs, standoff weapons, the whole shebang. When stealth isn't the primary concern, the F-15EX brings the heavy firepower.
And when that firepower needs to launch from the middle of the ocean, we turn to the F-18 Super Hornet. Operating off a moving aircraft carrier is arguably one of the harshest environments in all of aviation. While land-based fighters just need standard landing gear, carrier-based fighters are a whole different beast. They need heavily reinforced gear to survive violent catapult launches, an arresting hook to literally catch a steel cable when slamming onto a short deck, folding wings so they can be parked tightly together, and specialized materials just to resist the constant saltwater corrosion.
The Super Hornet's greatest superpower is its flexibility. A single squadron can handle fleet defense, drop precision bombs, and even do aerial refueling for other fighters. And working right alongside it is a highly specialized variant known as the EA-18G Growler. Now, the Growler doesn't drop bombs. It drops the enemy's network. It specializes in radar jamming and electronic attack, which actually perfectly sets up our next topic.
Section 4. The networked battlefield. Fighting without firing. You see, modern combat isn't just about physical planes dogfighting in the sky. It's about dominating the invisible electromagnetic spectrum. This is known as electronic warfare, or EW. It's the use of that spectrum to detect, disrupt, or deceive enemy systems. Today, you can fight and win a battle without firing a single traditional bullet. Modern fighters are constantly analyzing the radio frequencies all around them. Their computers can instantly identify if an enemy radar signal is just blindly searching or if it is actively locked on and is trying to guide a missile right to their exact location.
Let's walk through exactly what happens when a fighter does get targeted. It's fascinating. First, onboard sensors detect the incoming missile threat. Instantly, the aircraft reacts. If it's a heat-seeking missile, the jet spits out flares. These are intense heat sources meant to distract the missile away from the engine exhaust. If it's a radar-guided missile, it releases chaff, which are tiny metallic strips that burst into a cloud to create false radar reflections. And finally, the aircraft software initiates electronic protection, actively jamming and confusing the enemy's signals. It's a high-speed, invisible chess match happening in a fraction of a second. Let's pause here for a quick second, because if you only take one thing away from this whole deep dive, make it this: no fighter flies alone. American air power isn't just a collection of rogue mavericks out there doing their own thing. It is a deeply interconnected system of systems.
The invisible web connecting these jets is just massive. Imagine an F-35 using its stealth to sneak deep into enemy territory. It spots a target, and using encrypted data links, it instantly shares that exact targeting data with an F-15EX trailing miles behind it, allowing the F-15 to actually launch the missile. And supporting both of them are airborne early warning radar planes, tanker aircraft keeping everyone fueled up, and military satellites providing crucial GPS and communication links. They are all sharing one single, massive operational picture.
Finally, Section 5, the future of air power, the human and the machine. As incredible as all this technology is, it's absolutely useless without highly trained humans to manage it. In the pipeline to get there, it is brutal. Before a pilot even steps into an operational squadron, they undergo months of intense academic study. Then, they spend hundreds of hours in highly advanced simulators practicing things like engine failures, missile threats, and electronic jamming that are just way too dangerous to practice in real life. Finally, they participate in massive live fly events like the red flag exercises to truly experience the chaos of a simulated combat environment. But pretty soon, those highly trained human pilots are going to have a brand new kind of wingman. We're talking collaborative combat aircraft, or CCAs. These are advanced, autonomous AI aircraft designed to fly right alongside human pilots. These AI drones can scout ahead of the human formation, carry extra weapons, jam hostile radars, and execute the absolute highest-risk penetration missions. The goal? Keep the human pilots safely out of the deadliest zones.
And all of this is feeding directly into what's called NGAD, or Next Generation Air Dominance. Notice I didn't just say a new airplane. NGAD is a highly classified family of systems designed to ensure air superiority against rapidly emerging global threats in the coming decades. It's going to combine a new crewed sixth-generation fighter with those autonomous CCA drones, unprecedented secure networking, and even more advanced stealth capabilities.
Which leaves us with a truly wild thought to ponder. As AI gets smarter, seamlessly processing the vast mountains of data across this networked battlefield faster than a human brain ever could, in the future of air combat, will the most dangerous pilot in the sky even be human? Thanks for joining me on this exploration today. Keep your eyes on the skies and stay curious.